Hello, welcome to the Bakwas channel for self-paced tutorials on Internet of Things. This video illustrates the steps to configure database replication under MariaDB. The objective of this tutorial is to use two separate database servers in the farm to perform unattended database replication. The server with the database is referred to as the primary. The server that will receive the replicated database is referred to as the replica. The database servers run MariaDB, which is a popular open source relational database. Additionally, a monitoring service will be configured to keep an eye on the replication process. This monitoring service will run under Nagios Core. The terms master and slave have been used for replication in the past. The preferred terms for these two roles now are primary and replica. In this demonstration, the primary server is a Raspberry Pi 3 computer. The replica server is a Raspberry Pi 4 computer. Both servers run under 64-bit Bullseye, the current Raspberry Pi operating system. Also, naturally, MariaDB is installed in both computers. Both primary and replica will require some configuration for the replication process. This demonstration will illustrate only the basic and simplest configuration to establish database replication between primary and replica servers. Fine-tuning the configuration is beyond the scope of this tutorial. The Raspberry Pi operating system now provides an option to change the default name of the initial user. Please try to use this option whenever it is practical for you. Unfortunately, owing to other challenges, this new option could not be performed on the primary and replica servers used in this demonstration. But rest assured that changing the default user account name for all fresh installations of Raspberry Pi operating system is well underway. The two key assumptions to follow this tutorial are some familiarity with Raspberry Pi computer hardware. MariaDB was installed previously on the primary and replica database servers. When replicating across different versions of MariaDB, it is best practice that the replica server be at the same version level or newer as the primary server. Obviously, it is not possible to guarantee successful replication in a future version of MariaDB where the replica is at an older version or release level. This is not an issue at the present version level. This short tutorial illustrates only one method of database replication that occurs from the primary server to the replica server. It is possible to daisy chain the scheme. There can be another replica server to either receive replication data directly from the primary in concurrent mode, or the first replica server can be configured to forward to the second replica server. These configurations improve the availability of the database where downtime is not sustainable. There are 4 different configuration topologies for replication: basic, ring, star, and multi-source. In the basic replication setup, one primary server syndicates to one or more replica servers. This configuration provides superior read performance with the addition of replica servers. It is easy to achieve scalability that is proportional to the number of replica servers. Since there is more than one replica server, unplanned downtime of any one replica server is not a high concern. Ring replication provides scalability for both write and read operations. It does not handle conflicts. There is a single point of failure in the sense that if one primary fails, the replication is suspended. In the star replication configuration, all servers serve dual roles of primary and replica. This configuration provides the best scalability for read and write operations. Unfortunately, if data duplication filters are not used, then the configuration cannot handle conflicts. In the star replication configuration, all servers serve dual roles of primary and replica. This configuration provides the best scalability for read and write operations. Unfortunately, if data duplication filters are not used, then the configuration cannot handle conflicts. The multi-source replication configuration has the advantage that data from different servers can be resident on daisy-chained replica servers. Each primary server operates autonomously, and the presence of two replica servers in a daisy chain affords a higher degree of availability. The primary server requires two key changes to prepare for the replication process. First, the MariaDB configuration file needs some settings to enable replication. Second, MariaDB needs to enable permissions to perform the replication. It is best practice to use a dedicated MariaDB account username for the replication services. In this demonstration, the dedicated username for the replication services is replication underscore user. For one's small office, home office, SOHO infrastructure, it may be most prudent to have the same username on all database servers for replication purposes. In MariaDB console terminal, use the create command to create the replication user. If the command completes successfully, issue the command to grant replication privileges to the replication user. The key privilege for replication services is replication slave. The Replica server requires two key changes to prepare for the replication process. First, the MariaDB configuration file needs some settings to enable replication from the primary server to the replica server. Second, MariaDB needs to receive permissions to start the replication. Of course, before signing off, one should always check the status of the replication process too. After the new entries for replication services are completed in the configuration file of the replica server, restart the database server service using the restart option for the named service. The replica server requires two key changes to prepare for the replication process. First, the MariaDB configuration file needs some settings to enable replication from the primary server to the replica server. Second, MariaDB needs to receive permissions to start the replication. Of course, before signing off, one should always check the status of the replication process too. The use of global transaction ID eliminates the need to identify the log file and log position on the primary database server. This feature is available with MariaDB version 10.0 or later. The command to specify the connection settings of the primary database server at the replica server is shown on the slide. This command leverages the concept of global transaction IDs with the last option in the command example shown on the slide. The option is master underscore use underscore GTID. The command to start the replication process under the MariaDB console is shown on this slide. It is definitely good practice to validate the status of the replication process after issuing the command to start the process. The command to show the status of the replication is shown on the slide. Please note that the termination characters for this command are backslash and the letter G. There is no terminating semicolon for this command. Nagios Core is a popular infrastructure monitoring solution. There is a community-developed plugin to monitor the replication service at the Replica server. This bash script check underbar MySQL underbar slave status.sh processes parameterized output from a show slave status command and packages it for display under Nagios. This video tutorial was a very simple introduction to a more reliable environment for database operations. A simple database replication service was initiated from a primary database server to a replica server. The principles are applicable to MariaDB and MySQL database servers. However, slightly different configuration options must be chosen for the MySQL environments from a settings perspective. There is no perceived difference in the transfer of data from the primary server to the replica server under MySQL. However, most installations are migrating to MariaDB, and it is strongly recommended that all free open source software users or practitioners do so at the earliest opportunity. This presentation was prepared with assistance on special effects from Sufy Isma at Gmail. Of course, none of this would have been possible without the free open source software from Kdenlive for nonlinear editing, LibreOffice for documentation, MariaDB for the database server, OBS Studio for recordings, and of course Raspberry Pi for the platform services. The music is from the YouTube audio library. It is called Images of Tomorrow by Unicorn Heads. Also, to my family, my teachers, colleagues, and subscribers, a simple thank you is wholly inadequate for the journey through the years. Nevertheless, thank you again to everyone on this list for the encouragement, support, and understanding to help me to continue doing what I like doing, that is, to assist in a very small way to make more productive use of computer technologies. That's all, folks. Thanks for taking the time to view this presentation. Would love to hear from you with your feedback. You are always welcome to be critical in any which way you can. Until the next time, bye for now.